Hello everyone. Today we're going to be talking about the interquartile range and talking about how spread out the data is when we find the interquartile range. What is a quartile? All of these questions are going to be answered for you. So first of all, this is all involving something called the measure of spread. Okay? The measure of spread. How spread out is the data? And with measure of spread, one of the more common ways to figure out how spread out your data is using something called the interquartile range. Interquartile range. Now there's a lot to the interquartile range, so we're going to take our time and we're going to take it slow as we work through this because there are several steps to finding the interquartile range. First of all right, I drew us a number line here so that we can represent our data. We're going to put our data here, our data set, on this number line. So real quick, I'm going to go ahead and label my number line. I'm just going to do it by ones. I am going to space it out so that everything is nice and spaced out. We have plenty of room to see what's all going on. Okay? And I'm just going to plot my points real quick. All right, so we have one at 10, so I'm going to put a dot here at 10. We have one at 12. We have one at 9, 5, 8, 14, and then 11. So you can kind of see all of our data points now. Some things to notice. Notice that a lot of the data is right here between 8 and 12. We do have our lowest point kind of over here off to the left at 5, and our highest point kind of off to the right here at 14, all right? That the space between 2 and 14 is not as big, 12 and 14 is not as big as the space between 5 and 8. 5 and 8 are a little bit more further apart. So just things to start noticing about data that will help you further along in your measures of central tendency. So let's go ahead, and the first thing that we have to do is we have to find the median. Alright, so our steps, I'm going to write them down here, our steps for finding the interquartile range. An abbreviation, by the way, for interquartile range, a lot of people call it the IQR. Alright, so our steps down here is first you need to find the median. Okay, so find the median. We know how to do that. We put our numbers in order from least to greatest, and then find that number that is up in the middle of it all. So I'm going to go ahead and put my numbers in least to greatest. What's really cool about the number line is I can actually look at the number line and it shows me the numbers already in order from least to greatest. You just write down the numbers going from the left to the right. And so I'm going to go ahead and do that real quick. Ooh, that's a 14. All right. And now I am going to find, like I said, I am going to find the median, so that number that is in the middle. All right, to do that, I cross out one at a time, the lowest and the highest number at the same time. So 5 and 14 are gone. Okay, 8 and 12 are gone. And 9 and 11 are gone, leaving me that middle number, which is my median. I'm going to circle it. Now what's really cool about your median is if you notice, it cuts your data directly in half. Alright, so I have 3 numbers on this side, I have 3 numbers on this side. It cuts my data in half. And actually, those halves have names. This is all part of this interquartile range. So for the first part, oh no, there it goes. Okay, for the first part, this half down here is called the first half or the lower half. And this half up here is called the second or upper half. Okay, so it splits our data into 2 halves. Now to find the interquartile range, we actually now have to take and find the median of this first section here, and then we're going to find the median of the second section here. We need to know those numbers. So just like before, I'm going to look at these 3 numbers and I'm going to find the median. So I'm going to find the median. To find the median, I am going to be crossing out the lower, whoops, sorry. Having some technical difficulties here today. There we go. I'm going to cross out the lower and the upper at the same time. The lower and the upper at the same time. So the lowest number is 5, and the highest number in this lower half is 9, leaving me with 8. I'll just go ahead and keep it green. Leaving me with 8 as the median of my lower half. Now that lower half, the median is actually called the first quartile. So this is the first quartile. That's what that 8 is. All right, sometimes we just call it Q1. Let me write that a little bit better for us here. A little neater. Q1. Okay? Now I'm going to do the same thing but with the upper half. All right, so I'm going to do the same thing but with the upper half. So the median of the upper half, so that means 11's gone, and the highest number in that upper half is 14, and that leaves me with 12. And so this guy is called the third quartile. Sometimes we just call it Q3, just to make it shorter. So the first quartile is 8. That's the median of the lower half. And the third quartile is 12. That is the median of that upper half. Well, you're probably thinking, you have the first quartile and then the third quartile. What happened to the second quartile? Like, why did we skip that number? Well, we actually didn't skip that number. All right, this guy right here, that original median that we found, that original median that we found is your second quartile. Second quartile. We also call it Q2, and that's that original median that we found. So let's catch up on our steps here. The first step was to find the median of the whole set of numbers. Okay. Step 2 is to find the median of the lower half and the upper half. The median of the lower half, which remember that's called Q1, and then the upper half. Which remember we call Q3. Okay? Once you find out those two numbers, you can figure out the interquartile range. The interquartile range is pretty neat, okay? The interquartile range, the way that you find that, interquartile range, otherwise known as the IQR, equals Q3 minus Q1. So our Q3 is this 12, and our Q1 is this 8. And so all we have to do is subtract them, and we get our answer, 4. So the IQR is 4. Now what does this mean? What does this number mean? What this number means is that the center of the data, where most of the data is hanging out, the distance between the highest and the lowest is 4. So take a look again at your number line here. Take a look at your number line. As you can see here, most of the data is right here. Sorry, get my pen to work. Most of the data is right here. Notice that this guy right here was your Q1, and that this guy right here was your Q3. So where most of the data is centered together, gathered together, the range from here to here is 4. All right, so that's where that number comes from, and it comes in handy when you're trying to make box plots, which I'll have a video about that here in a little bit. But these numbers come in handy when you try to make a box plot, which is a visual representation on a number line, kind of like what we did here, of your Q1, Q2, and Q3. Okay, So the other thing that I don't want you to get confused about is if they talk about finding the range. The range, okay, is not, sorry, it won't let me pick my color. There we go. The range is different than the interquartile range. The range of this data set is the highest number minus the lowest number. Okay, so this IQR, as you notice, it's subtraction, yes, but it's subtracting two totally different things. So to find the range of this data set, you would take your highest number, which is a 14. This is your highest, okay? And you would subtract it from your lowest, which our lowest number here is 5. So the range is actually 9. So if they ask you about the range, they're talking about what is the difference between the highest and the lowest in your data. When they're talking about the interquartile range, they want to know the difference between your Q3, which is the median of the second half of data here, the upper half, minus the median of your lower half, your Q1. Okay, they want to know the central part of the data. What is the difference between where all the data is gathered up? Not how overall is all the data spread out. So make sure you understand interquartile range is different than the range. So they ask you to find the range. They want you to subtract the highest minus the lowest numbers. If they're wanting you to find the interquartile range, you have to find the medians and subtract Q3 minus Q1. There is a difference. So let's go ahead and we're going to find all the data we possibly can here in this second example. All right, so if we take a look at this again, I gave us a bit of I'm gonna move this up and out of the way here a little bit. I gave us a number line to show all of our points on there if we want to. So I am going to go ahead and label this number line real quick. Okay, so here we go. Our lowest number is a 14. Wow, okay. So I'm going to label these. I think I'm going to go by 10. So that way it just kind of gives us, or actually I think I'm going to go by 5. So we're going to start at 0, 5, 10, 15, 20, 25, 30, 35. A little smushed here. Hopefully y'all can read this. 50, 55, whoa, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 110, 115, 120, 125, 130, 135, 140, 145, 150, 155, 160. All right, so again, numbers are kind of smushed, but hopefully we can see what we're talking about here. And I'm going to go ahead and mark these. So we have a guy at 66. So it's going to be like right there, right on the other side of 65. We have someone at 71, so like right there. We have someone at 14 all the way down there. 135, so that's going to be right here. 68, so that's going to be right here. And then 70. Oh man, there's a lot of dots in that little area. Let me rearrange these a bit. So we have 70, 68, and 71. All right, so a lot of our data is centered around that 65, 70-ish area, but we do have 2 dots way far away from everything else. Now, as you can see, these dots that are super, super far away from everything else, they don't really group together with all the other things. They are separated way away from everybody else. So when we have numbers that are separated way away from everybody else just like that, we tend to call those numbers outliers. That's what they're called. They're called outliers. So this guy right here, we would consider him an outlier. What an outlier is a number that does not group together with all the other numbers. There is a huge space in between 14 and the next number, which is 66. There's a very massive space in between. And so because of that, we are calling him an outlier. You can think of this as like the planet, and this guy out here is like a moon. It's far away from the planet, yet it still belongs to the planet. It's just not part of the planet. Outliers can change your data. They can skew it. What that means is that they can throw off some of your numbers. This guy out here would also be considered an outlier. If my pen would work today, that'd be great. So this guy here, he's also an outlier. They can make your data shift, meaning all of your data is in the 60s. So think about it in terms of like a quiz or grades that you get in class. Say you're getting a lot of grades around 70, 68, like right around there. All right. So you would think that your average would be probably around, 70-ish, maybe at lowest like a 68 or a 67. But they should be right around that area. But then you go and you take a quiz and you get a 14 on that quiz. What is it going to do to your grade? It is going to plummet your grade. It is going to make it drop probably down into the 40s or the 50s. All right? Because of that one grade. It made your whole year or your whole 9 weeks, your whole grading period shift down a ton. All right? That's what an outlier does. An outlier is one little number that can shift everything over because it's not grouped with everything else. All right? And sometimes the shifts are good and sometimes the shifts are bad. For example, if you got a 135 on a homework assignment, that's going to shift your grade up for the good. It's going to benefit you, while a 14 would drop your grade down and hurt you. So it really depends on the situation of these numbers. All right, let's go ahead and do some math here. Let's go ahead and find the IQR. So remember, my first step is to put my numbers in order from least to greatest. So I have 14, 66. We're going to have 68, 70, 71, and then 135. Cool. All right, my first step, remember, is to find the median of all of these numbers. To find the median, I cross out the lowest and the highest at the same time. So 14 and 135 are gone. 66 and 71 are gone. Now remember, if I am left with two medians here, I can't just have two medians. I have to have only one median. So when this happens, I'm going to draw a line down the middle, all right? And I'm going to add these together. All right, when I add those together, I get 138. And then I'm going to divide 138 by 2. All right, I took the mean of these two numbers. I took the average of these two numbers, okay? And so when I do that, I divide 138 by 2, and I get 69. So what that means is that my median is actually a number in between these two numbers, between 68 and 70. And it's 69. So that's my median for this data set. All right, now remember that the median splits our data into two sections. We have the lower half, and then we have the upper half. Now notice that I included 68 in the lower half and 70 in the upper half. 68 is not my median, so I do not push it to the side and exclude it, okay? It is not my median, so it is still part of our data set. 70 is not my median, so I still include it in part of my data set, all right? So that is why 68 is included in the lower and 70 is included in the upper, because those numbers, neither one of them are my actual median. All right, and over to the side, I'm actually going to be keeping kind of a total of all the things that we know. So remember that this is Q2, by the way. All right, to find Q1, we have to take the median of the lower half. So let's go ahead. I'm going to switch colors here. I cross out 14. That's the lowest number in that half, and 68 is the highest number in that half. And that leaves me with 66. So 66 is my Q1. Okay. All right, the next thing I need to know is I need to know what my Q3 is going to be, my Q3, and that is the median of the upper half. That is the median of the upper half. So I cross out the lowest number in my upper half, which is 70, and the highest number in my upper half, which is 135, and I'm left with 71. So Q3 is going to be 71. So if I wanted to find the IQR, which is kind of what this whole video is about, what I would do is I would take Q3 and subtract Q1. So to do that, I would take my 71 and I'm going to be subtracting 66. And that would give me my IQR. So 71 minus 66 is 5. So what that means is that this data right here is spaced out in about the size of 5 spaces. All right, so 5 units. So that means that it's not very spaced out at all. The center of my data here is not very spaced out a lot. Now, other questions they may ask you from this, they may want you to find the range. Now, remember, the range is different than the interquartile range. The range is the highest number minus the lowest number. Well, the lowest number here is this guy, and the highest number here is this guy. So I'm going to be subtracting 135. Okay, so this is my lowest number. And this is my highest number. Just want to label it just in case. And so what I'm going to be doing is subtracting my lowest number, which is 135, minus, my highest number, which is 135, minus my lowest number, which is 14. All right, and that is going to give me the range, which is different than the IQR. The range is overall, all the data, how much is it all spread out. And overall, the range for this data set is 121 units or spaces. So that means it's spread out a lot. That means that the highest and the lowest numbers have a lot of distance between them. Now the central part of the data, the IQR, the interquartile range, not so much spread out, only about the distance of 5 spaces. So not very spread out, while the whole data set is very, very much spread out. From this data set, you could also figure out the mode. Is there a number that you see more than the others? All of the numbers I see are only represented once, so that would mean that there is no mode. And if you really wanted to, you could find the mean. So remember, to find the mean, you would add all of these numbers up and divide by how many there are. So let's do that real quick. We have 66 and 71. Plus 14 plus 135. So 135 plus 68 plus 70. 5 plus 7 is 12. And then I divide that number by how many total numbers there are, and there's a total of 6 numbers. There's a total of 6 numbers. So I am going to divide this by 6. 6 does not go into 4, but 6 goes into 42 7 times. I subtract. Bring that 4 down. 6 cannot go into 4, so that's going to be a 0, and I'm going to add a decimal point and bring it on down. 6 goes into 46 times. That's 36. I subtract. I get a 4. Bring a 0 down. 6 goes into 46 times. I subtract. Can y'all see that there's a pattern starting to happen? What that means is that you have a repeating decimal. So our final answer is going to be 70 and 66 hundredths repeating there. So we can find mean, median, mode, the range, the interquartile range, all from this data set. All right, this is a very difficult topic, so definitely practice this a lot. And watch this video over and over again until it hopefully makes sense. I hope that this helps you figure out how to solve for the interquartile range and how to use a data set to talk about how spread out things are. All right, I will talk to everybody later. Bye!